Hello, and welcome to today's episode of Rawkode Live. I am your host, Rawkode. Today, we're going to do some dabbling and experimentation with some new Pulumi features that enable multi-language packages. Before we get started with that, there's just a little bit of housekeeping. So first, if you're not subscribed to the channel, please do so now, and remember to click the bell so you get loads of notifications for all new episodes as we explore the vast cloud-native landscape together. And if you want to chat and talk cloud native, Kubernetes, and anything in between, we have a very active Discord server. Feel free to pop in there, say hello, and I look forward to meeting you. All right, now joining me today to introduce me to this wonderful Pulumi awesomeness is a returning guest, Lee Briggs. Man, how's it going?
Not so bad. How are you?
Yeah, I'm doing well. I'm looking forward to seeing what new shiny stuff you've got cooked up for us today.
Yeah, this is really new, so really on the cutting edge. I'm really excited about it, and I think probably best first step is to talk a little bit about what we're going to be doing.
Yeah, well, why don't, just for anyone who's not aware of you, you tell us a little bit about you, and then we'll talk about the thing.
Sure. My name's Lee Briggs. I work at Pulumi as a developer advocate and formerly in the engineering team. I originally from the UK, living here in Seattle in the west coast of the US. So it's good to hear a familiar British accent.
All right, thank you for sharing. Okay, now enlighten us. What awesome thing are we doing today?
So you need to provide a bit of context here, especially if you've never kind of used Pulumi. Pulumi is obviously an infrastructure as code tool that allows you to use what I like to call Turing complete languages. So instead of using declarative languages like YAML, you can use imperative languages, but we declare the imperative language pushes towards a declarative state, which is super powerful. And our customers love it because it means their front-end engineers who are familiar with TypeScript or their back-end engineers who are maybe writing stuff in Go, they can use those same languages that they're using their application lifecycle to actually define infrastructure as well. We have a mechanism within Pulumi that allows you to group all of the different infrastructure resources that you are defining into what we call a component. And if you're familiar with stuff like Terraform, you might know of a module, or if you are familiar with the CDK, you might be familiar with constructs. Components are our mechanism for creating reusable infrastructure. And what we usually see is that companies like to define like best practices in these components and then share them out within their organization. The problem with that is that up until now, when you've defined your component, and let's say you've written it in our TypeScript SDK, you can only really share that with other people using the TypeScript SDK. So like your ability to kind of like create community modules, or maybe in large enterprises where you have multiple programming languages in your stack, you've had to rewrite it multiple times. And there's a couple of really great examples which where people have gone to the trouble of writing their component SDK in Go and then TypeScript and then Python, but the maintenance overhead just kind of gets away from you really quickly because you're having to write things in 3 languages and you might not know 3 languages. So a few weeks ago at our 3.0 launch event, we announced what we call multi-language components, which quite honestly, as a technical feat, is so amazing. I don't fully understand like how it's possible. I mean, I understand the technical ability of it, but I'm still like blown away that we're basically able to do this. But what it means is that you can create a shareable component in one language and it will generate the SDK for Pulumi in all of our supported languages. So that's what we're going to be doing today. We're going to write a example component that will allow you to like define the best practices for a deployment. And I think we decided that the best way to kind of show this off is in the Kubernetes world, where like if you have an internal Kubernetes platform, you probably want to define best practices for a deployment within your organization, like the required number of replicas, and then just allow it to be configurable with just the image you want to run. So we're going to define that. We're going to write it in Go, and then we're going to show how that generates an SDK in 4 different languages and see an example of deploying it in TypeScript. And if we have time, we'll do a Python example as well. So it's going to be a bit of a journey. I've written like 2 of these so far, and I'm still finding some of the, some intricacies, but hopefully we'll be able to kind of show off what the capabilities of this are, and we'll get an idea of how powerful it is.
Awesome. The timing would generally couldn't be better, because I've actually been working on something that could really leverage this. Like the cluster API bindings that I've been working on for actually deploying Kubernetes clusters are all done in TypeScript, just because that's the language that I prefer to go. But the cloud native ecosystem is full of Go developers who want to work in Go, and if I can expose these bindings to them through that, that would be amazing. So I am super excited to see this work.
Just a final thing, we're going to be using the Go SDK today, mainly because Go's ability to build binaries that you can then reshare is super, super powerful. So I like to write these in Go. You can write these components. If you're a Python developer or a TypeScript developer or a .NET developer, you can write these components in whatever language you think is best. But the caveat is that the end stream user will still need to have Node or Python installed if you write it in those languages. So Go is really nice for this, because all you have to do is give the users a binary and they're off to the races, basically.
Nice. All right, show me the ways.
Okay, so I sent you a link before we started. We're going to look at the Pulumi Go boilerplate provider. So this is on our GitHub repo.
I'm just going to leave the Pulumi homepage up for 10 more seconds, because I think it looks so awesome these days with the rebranding.
So. And I love the rebranding, and shout out to Zach Chase, who slaved away for hours and hours kind of putting this together and coding it all up. I think it looks awesome too. So yeah, really, really cool. So the starting point that we have already kind of done a little bit of, we've got a template provider here that we call the XYZ provider. And what it's basically doing is showing you an example of creating a static site in AWS. But the whole point of this is to start off with something that allows us to kind of build something out. So you already forked this into Rawkode Pulumi -production app, which we see here. So the first thing that we need to do is we need to kind of go through a bunch of this stuff and just update the name from XYZ into what we're going to call production app. So the first thing we'll do is open up the make file. And you'll see at the top there, the pack is XYZ. So we'll change that to production app. And then below that in project, you need to make sure the project is Rawkode rather than Pulumi. And then we'll just scroll down and make sure there's no other missing pieces. I don't think there is. And just to quickly go through what this is doing, this is just a make file that is going to generate all of the SDKs once we've finished building this out, and then also install them locally so that we can test it. So you'll see it's going to generate what we call a provider binary, and then it's also going to generate all of the different SDKs. So this is what we're obviously going to be using in a few moments. Next step is we're going to open up schema.json. So this defines the shape of the actual component itself. So it defines inputs that you're going to put into the actual. No, we're going to do it manual, Paul. We're going to do it so that people understand what is happening. We're going to do it the right way. So this defines the inputs and the outputs of the actual component. So this is going to allow us to set configurable values for our users, and also what things that they might want to use elsewhere. So we're going to call that production app, and then on line 4, we're going to switch XYZ to production app as well. And then instead of static page, we'll call it deployment, I think. So a deployment of a production app. And then the input properties, we're just going to clear that map out for the time being, I think, is probably the best way to go about this. So it's actually starting at line 6, sorry. And I don't want to kind of, so over.
Do we need empty out the required inputs too?
Yes, we're going to click. So that's going to be an empty array, and then all of the required properties.
Okay, so this is just like a JSON declaration that says this is the thing that we're creating. These are the inputs that it has, and then this is the other stuff that can be layered on the top to customize it in some way. Is that like a function signature in a weird kind of way?
Yeah, that's probably a good way of putting it. Yeah. So I'm also just gonna clear out this index content here, because we're going to fill that out in a few seconds. So this is going to show us like all of the things that the users are going to be able to configure, and then also the things that they might want to pass to other Pulumi resources later. For example, you might want to generate the deployment name and all that kind of stuff. We're not going to use this today, but it's just a nice thing to know later on. And so then next up, we're going to define all of the language dependencies. And obviously, for our example, we've got C#. We're going to, in the example we're using AWS, we're not going to use that. We're going to use Kubernetes. So on line 14, we're going to change that to Kubernetes, and then it's actually 3 star. Go, we're going to change the import base path to our name, so Rawkode Pulumi production app. Yeah, don't forget the Rawkode there. And then at the end of the XYZ is also production app. Yep. Node.js dependencies, update the AWS to Kubernetes 3.0.0, and then finally Python. Again. And what's great about working at Pulumi is you get to learn all the different dependency management systems and how they all work differently. So you're kind of dealing with so many different SDKs at a time. You end up kind of learning the intricacies of setup.py and all that kind of stuff.
I think there we go.
We are working on some authoring improvements here, so we're hoping that we're working on a way that this will automatically get generated, but for the time being, it's actually kind of nice being able to kind of do this manually because you get to kind of think about a little bit about what you're doing.
But then I don't get to show off my wonderful, command line knowledge.
So the next thing that we're going to do, yeah, I mean, that's probably, at this point, we can just go ahead and do that.
No, I'm sure we're good, right? Yeah.
Yes. Okay. And so then the final thing that we're doing here is we're going to actually update the directory. So if you go back to your so in the provider directory, there's go.mod. At the top, the module name is going to be Rawkode Pulumi production app. I don't know if you want to go for Go 116. That definitely works. And then the Pulumi package and SDK is going to be 3.3.1. And you'll need to yank the, there we go, perfect. Okay, we'll keep going. And now we're just going to update some directory names. So if you go to your workspace again, in the package directory, sorry, no, my apologies, in the command directory,
yeah.
rename those. And then rename resource as well. And then I think there's got some imports in there as well, so you'll need to drill down into there. So this is all fine. What this is doing is it's reading in that schema, and it's going to emit the SDK from the schema. And then here.
I don't think I see anything. Oh, there we go.
There we go. I'm sure we've missed one of these, but we'll figure it out. And then don't forget the online 20 as well. Don't forget the raw code for Pulumi in the in the import name as well. Kind of manual at the moment. We are working on the authoring experience for sure. So anything in the examples or SDK is going to be fine. All of the stuff that we're really looking for is in the provider thing here. So we are going to be looking at the provider package in a moment. So what I would recommend is just blowing away the SDK directory because we're going to regenerate that every single time.
What about the examples directory?
And that as well, yeah, that's probably easier.
You sure?
Yes. We're not going to be using that just yet, I promise.
All right, we can ignore the README. So that means we got just the provider one now. So let's jump back.
Yeah.
Into there.
So, yeah. It's in command, I think. In the provider command. Sorry, there's two command directories. There's command and then provider command. Oh, there we have provider package.
Oh, right. Okay. Yeah, there's one.
So, production
app.
app.
Production app and deployment, right?
That's right, yeah. And that's it. So What we're going to do now is we're going to rename the static page.go into production app.go. Or we're going to rename that. I like to call it deployment.go because that's what we're going to be doing. And then if we open that up, okay, so this is where we're actually going to do all of the logic that we're actually going to kind of use to create our provider. So currently we're using the AWS provider. We can completely remove line 18 and just do, because the Kubernetes provider is laid out slightly differently. And you're way ahead of me already. So you,
Yeah, but I'll get it all wrong.
To me, that actually shows that it's relatively intuitive. So yeah, so we're going to create a deployment with deployment args. We haven't decided that we're going to have index content yet, so let's get rid of all of that. And then line 29 and 30, we can get rid of those because those are going to be the actual outputs that we're going to create. We're not going to do new static page. We're going to do new deployment.
Okay, so I should just rename it rather than delete it?
Yeah, just rename it. Yeah. And that takes deployment args on line 32. And then we also redirect to deployment args there. And then 37. It's not, it's just a component is a new, yeah. And then here you can see where we register our component. That will be production app, index, deployment. There we go. We're not going to be creating a bucket, so we can get rid of that. And you can see that this is all just going to be creating, leave that. We're going to need that in a few moments. So what you want to be removing, and I can probably jump in here and help. I'm making you do all the work.
Yeah, I'll just sit back and relax.
All right. You've already done it. So then the final thing that we're just going to remove is this register resource outputs is going to be the thing that we're going to export in our production app. We're not going to export anything. So this can be just an empty Pulumi map. So lines 44 and 45 can go. Beautiful. Okay, so what is that, like 5 minutes, and we have bootstrapped our provider, and we're ready to actually add some stuff to this now to actually make it useful. So we need to do a few imports. What
you
we
happy
need to
take a question just now?
Absolutely.
All right. We got Paul has answered it in the comments, but let's get Andreas a good answer. So no offense, Paul. I love you really. But Andreas is asking, does that mean... Oh, that went away fast. Stay. Does that mean that consuming several public components might require to have Node and Python available even if the stack itself is defined in Golang? So you're basically generating API stubs. I don't know why that keeps disappearing.
Yes, basically. So like the language that you're actually using, like if you're consuming this component in Python or you're consuming this component in TypeScript, you'll need those available to actually kind of create the infrastructure. Because we're writing this in Go, you'll need to have the actual Pulumi binary locally installed as well, and we'll generate that and put it in the path. But because we're defining it in Go, if you want to consume this in TypeScript, you will not need Python, as an example, right? So this is relatively common for some of our larger customers who have like clean laptops, and they're like, we want this specific version of this specific, language. You'll only need the language you're consuming it in. You don't need all of Pulumi's supported languages installed to use this because we're writing it in Go. Okay, so hopefully that answers the question. Okay, so what we're going to do now is we're going to use the Kubernetes SDK to actually define a namespace, a deployment, and a service. This is just a hypothetical production app. So I'm going to copy these for you into the dependencies so that I don't have to tell you to type them all out. So these are all of the different types of dependencies. If you scroll up to where the dependencies are, we're going to be using apps v1. If you are familiar with Kubernetes, this will look pretty familiar. It's basically just the Kubernetes API. And we're going to use apps v1, core v1, which is where the namespaces are, and meta v1 for all the different types and stuff. So I've imported those for us. The next thing that we're going to do is go back down to our new deployment. Well, if we scroll down a little bit.
Yep.
And this is just where we're going to start to actually define all of the stuff that we want. So what I like to do here is like set up some labels that we're going to pass to all of these resources, because it kind of shows that you don't have to kind of repeat yourself. So below where the arguments is on line 39, just declare a new variable labels. And we're going to do Pulumi dot string map. And we're going to add some labels of app. So the actual, these don't actually need to be a Pulumi.string. So it's just a app.kubernetes.io /app is what I like to call that label. Sorry, I'm not doing a great job of. Yeah. And then this value is a Pulumi.string. But what we're actually going to do is just pass the name from the actual deployment. So we'll do Pulumi.string name, and that comes from here. And I don't know if you can see me highlighting in the VS Code because I've turned the live stream off, but cool. So then that's going to come from there. And then also we're going to do app.production. And again, this is just a nice label to pass through to everything. .instance /name Pulumi.string name. Cool. Apparently, I have not learned to type this morning. So then we can just pass these to all the different resources that we're going to create, which is nice and simple. Next thing we're going to do is we're going to create a namespace error. And this is where we start to use our dependencies, and I think you're going to have to go get them so that we get all of the type hints.
All right, let's comment now so it's happy at least.
Yeah.
Oh, I'm in the wrong directory, right? So it was
it's in provider. It's in the provider directory.
And yeah, we got a go mod, so we'll go get.
Interesting. There we go.
I never understand go mod. I just keep typing commands until something works. So.
I think you've just described my whole career. So then we should hopefully get the type hints now. So if we, and I'll let you.
Yeah.
And so then it will be new namespace. Yeah. That takes the first argument is the context, or CTX. So that's the Pulumi context.
And then
all of these take the community. Yep, then the name, and then it's so it's a pointer to core v1 and ampersand, sorry, core v1 dot namespace args, like so. Yep. Then we need to specify some metadata. So yep, let's populate that, and that takes and meta v1. Object meta args, and then we'll put the name. I think it's capital N. Pulumi.string name, and then the labels obviously can come from the actual labels variable.
I've forgotten how to go. I've been writing Rust all week. So bear with me.
Yeah, you've gone full hipster then. What is missing here?
Oh, why have I got two?
That'll be it. And there's another one at the end there. There we go.
Right,
okay, so then we're doing go, so we need to check the error.
Of course.
What I like to do here is so this object returns two things. It returns a deployment and it returns an error. So we're just going to return nil. And then what I like to do is actually return a little bit more helpful error. So I do format.errorf. Sorry, it looks a little bit like, yeah, there we are. Error creating namespace, %v. I do %v because it's nice. And then the actual error. And I think we'll need to import format as well.
Yeah,
it looks like it's
VS Code did it, so we should be good.
Okay, so that would create our namespace for us. Let's create our deployment. We will use the namespace later, but for the deployment, we're not actually going to use the variable. So we're going to do empty variable. So error equals, and it's just equals. Yeah. I'll let you take over from here.
Oh, all right. So we want a core v1.
It's apps v1 because it's a deployment rather than core v1.
What did we import?
Oh, it's yanked our definition. Let me grab
It
it
is
again.
apps v1, right?
Yeah, it is, but it's actually the import has disappeared because I'm guessing we're not using it. So right. I've added it back at the top there. Dot new deployment, yeah, and then of course that takes a context, a name, and then apps v1 deployment args, and like if you're familiar with Go, this all starts to seem a bit familiar after a while. Like, but the deployment object is a little bit more complicated. So that I think you've added an erroneous space there on 56. Let me get rid of that for you. So then that takes metadata as well. So we'll start with the metadata in caps. And it's object meta v1 object meta args. I think you need a pointer, so let me add that for you.
Thank you.
And then so we're going to grab the namespace that this deployment deploys in from the namespace variable. And this is Pulumi's outputs at work. So it will be namespace. And you can kind of finish it off from there. Dot metadata. So it looks like this. So it's metadata dot name.
Yeah, you want the name of it, of course, not the object.
And then you actually need to get the element as well. So it looks like that. So if you're not familiar with Pulumi, this is the way that we create dependencies between two different objects. So we're getting what we call the output, the name from this namespace. We're getting that output and we're passing it to a new resource. This allows Pulumi to know that it needs to create the namespace first and then create the deployment second. And this is how we're able to use imperative languages and create this dependency graph, which is super powerful. So then we're going to define the spec. And this would be and apps v1 dot deployment spec args, and this is where the ability to do strongly typed languages becomes really handy, because you're getting all of the it's really hard. It's surprisingly hard to make a mistake here because it's telling us what it needs. Label selector args, match labels is the labels, and you're probably understanding why I set up those yes. that variable now, because you can obviously make mistakes there. And then we want replicas, and this is kind of where I like to point out that because we, as the people authoring this SDK, are the experts, we want this to be a hypothetical production application. And we know that a production application is not one replica, right? We know that. We don't want to make this configurable. So let's hard code it so that all of the people consuming this particular component, they're always going to have a highly available application. So we'll make replicas of 3, and we're not going to let them actually, let our consumers modify this, if that makes sense. Obviously, we are going to be adding arguments to this at some point, but I guess the point I'm trying to get across here is when we're defining these components, my thought process is that you only should have input arguments that you actually want your users to be able to modify and consume. Okay, so we're going to do a template and call v1 pod template args. More metadata, because Kubernetes loves its metadata. Object meta args, labels, and then the spec for the actual pod spec args. And this is where we're actually going to be defining the container. And this, I think, is, let's see if this is correct. Pod spec args. Yep, containers. That takes an array of containers. So Anchor v1 container. And this live share is really hard. It's just that little delay from like doing things locally is an interesting Anchor v1 container array. And the reason that we have to do these special types with Pulumi is because these values are like, this is not a standard kind of slice, and it's because these values are like computed, so we don't know them up front. Core v1 container args. And I'm going to let you, this is your show, so I'm going to let you finish round this one out. So we're going to take the name of the actual container, will be pulumi.string. And let's hard code this for now, the image. So what we'll do is we'll hard code the, we'll make that name, or main is fine, yeah. Nginx is fine. Ports. And that takes a Core v1.
Let me just check. Yeah, core 1 container port input array. So
Core v1 container port array, and then Core v1 container port args, and container port, let's call that 80, I guess. Pulumi.int 80, yeah. Okay, and then there's one, there we go. So this is your deployment and your namespace. Final thing is the service. If you, hopefully the cluster that you've set up can support load balancer services. I assume it can.
Should be all right.
We'll give it a try, huh? So we're going to define a service, and we're not going to use this. So equals core v1 new service. And of course that takes a context, it takes a name, and then it's core v1 service arg. Ooh. Metadata, of course.
Of course.
And I think we can just
copy that, I think, yeah.
Make our lives a little easier and copy this, you know. It's just occurring to me that what we could have done is set up a variable for that, but this is Go. It likes to be verbose, of course. Ports and core v1 service port array.
Got a wave from Mark. Hey Mark, thanks for joining.
And core v1 service port args. Port is Pulumi.int 80. And I always forget, this is the actual port that the load balancer listens on. So target port is Pulumi.int 80 as well. I think, oh, we need a type as well.
Yes. Right now that's just going to be a cluster IP service, which is okay.
Yeah. Pulumi.string. We can always remove this if this doesn't work, because we're just showing how it doesn't have to be. It doesn't actually have to be a production-ready application.
So this
and then
is
the label
a
selector.
cluster API cluster running on bare metal on Equinix Metal, running MetalLB, the Equinix Metal CCM. I mean, there's a whole bunch of stuff here it's configured. I'm sure I got it all right and the load balancer will work, but we'll see.
Well, if it's got MetalLB, it should work, right? And we have a problem here, and I'm not sure.
Yeah, it was just a comma. I fixed it.
I'm still getting an error on line 102. Maybe my live share is not updating.
Mine's is all right.
Okay, well, we'll see how it works. So this is defined all of our infrastructure, right? So we could generate this SDK and then we could actually consume it, but it's not really very usable, right? Because we're obviously going to want to deploy more than just Nginx, right? So here is where we start to kind of set up some of the parts that allow us to allow us to make it configurable. So we're going to scroll all the way back up to our production app args. Sorry, our deployment args.
Yep.
And this is where we're going to actually start to add the two things that I can think of that we need to allow to be configurable is the image. So as part of the struct, we'll create an image, and this is a type of Pulumi.string input. And I think your colon has vanished at the end there. And then we also need to put a type on this. So the way this looks is, and I'll fill this in so that we can. So this is, oh man, VS Code is giving me a nightmare. So what we need to do is add, very similar to what we would do with JSON, we need to do something like this. So that means that when we read the schema in, this is the value that it's going to read from that schema.json. So we're going to need to update that in a few moments. And then the other argument that we're going to want is the port. So let's we'll make that configurable to our users. Pulumi.int input. Yeah, Pulumi. There we go. And so now we can actually pass this stuff to our deployment as well. So if we scroll back to our deployment.
I'm worried that Go format hasn't kicked in. That normally means that we have an error. Yeah, we've got. Oh no, wait, that's a breakpoint. Did you add a breakpoint?
I did not add a breakpoint. I don't even know what they are.
Right. Okay. Well, I'll assume it's fine. I don't see any.
When this builds, it'll tell us what the problem is.
Oh no! Now I've got an error on that line. Okay. I didn't have that error there, so we're missing a comma somewhere.
We're missing the closed bracket, I think.
Right, there we go.
Hang on, let me.
Did it format at the top? It did. Okay, we're good.
We're good. See, yeah. Look, this is this is pair programming at work.
It's weird that I justify whether my code is going to work or not, whether the formatter kicks in or not. If the formatter doesn't kick in, I know that I've broken something.
So now we're actually going to pass those arguments to our deployment. So if you scroll back down to where we defined Nginx, we can change that image to args.image, and then the container port here on 79 we can do args.port.
Easy.
Okay, so now we need to update the schema so that we can actually tell Pulumi that these are required when we generate the SDK. So if we go back to our schema.
Oh, yep. That's right. The JSON.
Yeah. So this is where these input properties come in. And so what this needs to look like, and I need to actually look at a reference example here because we're still.
I'm just making it up.
Yes. No, you're basically right, but they need to be lowercase because that's what's on the actual thing. And then here is where we define a map of properties. So we're going to do image. We need to define what the type is because obviously we generate strongly typed libraries. So we'll do string like so, and then we get to add a description for the type hints. And hopefully you can see like this is what are going to allow our users to get a little bit more information when they're using this. So yep. The image to deploy in your production ready application. And then it's JSON, so it doesn't want the comma there. And then port type is integer, description, the port your application listens on in your Docker. Well, it's not technically Docker anymore, so we'll just go in your image.
Container image.
Container image, yeah, that makes sense. So these are the things that are going to define what our input types are. This properties thing here, we're not going to use this today, but this properties is the thing that will allow you to say, if you've used Pulumi before, like all the outputs that we have, like you can also define outputs. So if we wanted to, we could say like return the load balancer that has been created that you might want to use in different things. We're not going to do that in this particular case because it's supposed to be a relatively simple example. So I think that's everything, but we'll find out when we start to do some of the fun generation stuff. So if you go back to your terminal.
Can we just summarize what we've done there? In fact, I'll summarize it to you and you can tell me if I got anything incorrect.
Sounds good.
All right. So we are using the Pulumi component provider Go boilerplate repository. This can be used as a template to provide the base for any multi-language Pulumi component.
Yes.
What we did there was just really go through and do some rudimentary changes. We were modifying the XYZ, which is the example name for the component, to be our production app. And then we modified the static page, which is just one of the resources that the boilerplate or provider starts with. And we've modified that to consume the Kubernetes API, provide a deployment, and a service. And we've exposed through this little JSON schema style document the ability to understand what input properties there are, as well as which ones are required. And then we just done a little bit of glue inside of the Go code to actually create those resources.
That's exactly what we've done. That's exactly what we've done. And the process is exactly the same for all of the different languages. If you want to write one of these in Python, you're basically going to do the same thing. You're going to define a schema if you are familiar with like TypeScript, and you basically, I think of them as interfaces. So this schema is the interface that like the consumable interface for all of the different, like the shape of this thing that we're going to define. I think it's TS. It's TS, not TypeScript.
Yeah. So is there a boilerplate for all the supported languages in Pulumi then that people can just go and use as a template and get started with their language of choice, right? Okay.
I think the only one missing right now is .NET. I think we've got that on the way. But Python, we've got a PY. And if you go and look at the provider in the TypeScript example, you'll see that like inside here, this is like the Go binary. So if you go into command, we're still using the same Go binaries to generate all of this stuff. But if you come back up to the root level, I'm actually like completely blanking on where the actual TypeScript code is here. Hold on, let me just have a look. I looked at the Python one before we started.
Oh, there's TypeScript in here. It's under provider command resource, and then it looks like
there we go.
Yeah, we got some TypeScript here.
So you can see it's doing very similar things. It's going to read the bunch of different stuff, and then the actual static page is defined there. And so again, like the only caveat with this is that your downstream users will still need to have TypeScript on Node installed. So as part of your, we are looking at some examples, like you can embed these TypeScript files into, you can bundle these up as TypeScript binaries and all that kind of stuff. We're looking at different ways to make that easier. But it's essentially your downstream users, because this is obviously going to invoke this Pulumi program, you'll still need to have TypeScript installed.
Yeah, I wonder if you could just embed like a Node runtime. I think there is a couple of Go versions into binary. Of course, the size of that may be a little bit ridiculous at that point. But we
have our hackathon coming up. I'm going to come up with some wild and crazy ideas for things we can do here, hopefully. And then there's the Python one as well. So if you do py-boilerplate, again in provider.
I don't think I've ever looked at Python.
So the actual code is in XYV provider at the top there.
All right.
And then static page at the bottom. I have strong opinions about Python, which I won't share here because I may get piled on Twitter. But yeah, like if you want to write it in Python, then go nuts.
But that's the joy, right, of why we want to use Pulumi over any other tools like this, is that flexibility to stick to languages, runtimes, and toolchains that I'm already familiar with. Like I don't have to go and learn anything new. So, whatever your poison is, go for it.
And my perspective as well is that, application developers especially, like in a lot of cases they're kind of getting exposed to cloud environments and cloud engineering environments that's already super confusing, and then when you add a new kind of like declarative YAML document on top of it that they might not understand, it's a massive learning curve. Like imagine somebody, especially I always kind of compare it to as an infrastructure engineer, imagine if somebody told me that I had to learn front end and back end at the same time. Like, you're just throwing things at me that I don't really understand. So it's like, my perspective has always been using these familiar languages is a really nice way to kind of gradually introduce people to new concepts, but using something that they already know, it's a much better way of learning in my experience.
Oh yeah, definitely. All right.
So I think we should generate this now. Let's generate this. So let's go to a terminal. And we should be able to do, and I need to remember the make. It's actually, we use the make file. Yeah, so we need to first run make generate, which will generate all of our SDKs, and it's also going to tell us if there's any problems.
Can I just go for it?
Let's go for it, yeah.
I'm in the wrong directory.
You're in the wrong directory.
All right, now I'm not feeling as brave anymore, so I'm just going to do generate. I've lost my confidence. So you can see,
well, this is kind of this will show you what's actually happening here. We're running go run to actually generate the. We're passing the schema in, and it's allowing us to generate the Go SDK, and it's going to generate the TypeScript SDK and all that kind of stuff. It's taking longer than I expected. Oh. Excellent, we have an error. This is what we love to see. So let's have a look at what we've done wrong here.
An assertion has failed.
Oh, this is a lovely error. We've obviously made a mistake. So it's happening in the emit SDK portion. I'm just going to look at the code real quick.
It's all right. You can say I got it wrong. I won't be offended.
There must be a problem in the schema itself. We have an error here too.
Yeah, we haven't updated any of this actually. We haven't updated anything below here. And in fact,
did we forget something? Did we forget something? Let me look at my example that I wrote of 3 weeks ago.
Paul Stack says the token is incorrect.
The token is incorrect. Want to give us a bit more help here, Paul? I'm half tempted to just bring him in here at this point.
Yeah, come on, Paul. Show us what's wrong. Which token? Did he see that from the error message? Let's see. We got main.go.
The token is incorrect.
Gen.
I'm gonna.
Maybe something in the schema. I think the code looks alright, and it's not.
I think it was something in the schema as well. Yeah. Did we get the token wrong in the schema? Production app index.
Paul asks, where is our declaration of the type? Are you being cryptic on purpose?
We both know Paul well enough to know that he probably is.
Okay, so where is our declaration of the type? All right, let's turn this into Crystal Maze style deployment. Start defense, please. So this is our declaration of what a deployment is. Are we missing anything in a struct?
Nope. That struct will output the that would have the output. So no, that should be absolutely fine.
Okay, we're getting some more hints from our good friend here who suggests that we open schema.json, we take a look at the resources. What is the first item? It is what I expect it to be fair.
Yeah, is component true, input properties. I actually have a working version of this as well, and it looks exactly the same, so we've missed something. Can you rerun the make again? I want to take another look at the error.
Yeah, I'll send Paul a link. He can just jump in for 5 minutes if he wants.
So this is in command. Production app provider.
All right.
Command. I love it when we get just random extra guests.
Well, until he learns how to articulate his thoughts properly through the chat system in order to remove the errors that we are suffering on a live stream, he will have to suffer the fate of joining us on stream.
So what I think he's talking about, if you go back to the VS Code, I'm in main provider. So if you look here,
and Jen or resource one. No, that was Jen.
So this is where the error is coming from on line 24, production app, but it looks right to me. Oh, maybe that should be deployment. I think that might be, no, that's the provider name. Interesting. This is the great thing about using brand new stuff when you are in a live stream. I'm pretty confident we'll get this working.
All right. Well, Pierre is asking, did we remember to sacrifice our firstborn to the demo gods? I mean, no. I knew I forgot something. I didn't quite remember what it was. Okay, sorry. What was your hypothesis there? So let's look at this error message. I'd like to understand what assertions is the generator doing here against our schema and our code?
So it's looking at the actual provider name at the top of the schema.json.
Which is our production app here.
Yeah, I think what I'd like to try is let's try changing. If you go back
What's
to the
index
other,
here?
That's just like the actual place in the Pulumi resource model where it lives. That's the only thing that it's not. That I know that is definitely shouldn't be changed. I think we should try calling it deployment. Like the actual token name in the previous file. So let's try changing that to deployment on 24. Yeah, let's give that a try.
Well, this is now complaining about Pulumi schema.
That's because it doesn't exist yet. It will generate a schema.go file when this step works.
Right, okay. It seems to be the same.
Has failed. What? Okay, like my idea here.
Hey, Paul.
Hey, folks. So Lee, I think the issue is that your import base path may not be correct in your Pulumi schema. It's trying to tokenize what's coming out of further down that list, and it doesn't seem as though it's correct.
Oh, I see what you're saying. Okay, so you're saying that line 31 on this schema.
Yes.
You think that that should be deployment at the end there, so lowercase deployment.
So not necessarily deployment. It needs to be the name of the actual SDK that you're trying to generate. So, like for example, for me, my import base path would be github.com/stack72/Pulumi GCP Cloud Run Global /SDK/go/GCP Cloud Run Global. So it all depends on what you're actually trying to generate at the back of the package.
I think he's right. That needs to be deployment. Give that another try. I think that's probably.
The funny thing is, Lee hates it if I'm right.
I do hate it if you're right. Absolutely. So what I'm going to recommend here is I'm going to get this closer to the version that we actually had working. So I'm going to change this to production app, and then. Because I knew this was gonna happen. What I had this was as production app args, production app, because these are all just structs at the end of the day. Let me look at my example. New.
Which file are you modifying just now?
I am in the actual provider that we created. So, although it's bouncing me around a little bit. So I'm going to do new production app. Production app args. This is really great because we can feed this back to the team as like this error message is just not very helpful. So we obviously need to open an issue for that. Make sure that we get that right. So this is what when I ran through this yesterday to make sure that this was actually going to work. I actually called this production app args rather than production app and deployment. And again, it's just structs, but I think we missed a token somewhere, like Paul said. So let's give that another try and see what happens. Oh wait, I know. Oh, I know. I've just figured out what it is. I know exactly what it is. So if you see where I am right now.
Yeah, I'm following you.
So this is the problem. If you scroll down, we've still got a reference to static page. We've still got a reference to static page args here. So this should be. Now we've changed it. That should be production app args, and then this needs to be new production.
Yeah, line 29 has a static page on it too.
29. Construct.
Although
construct deployment. The function is still construct static. Just rename the function to construct deployment.
All right, there we go.
There we go. That, I think, is what the problem was. That does not look correct. Still getting an error.
Yeah, we've probably missed. Yeah, we've missed one changing back. So deployment.go line 58 has that deployment args on it.
Oh no, that's correct. Because that's the actual.
Oh yeah, that's the actual deployment.
Yes.
What about this one here, line 39 at the end?
That looks wrong. Yeah, that looks like it should be production app because it's going to return an instance of a production app. So let's try that again.
No.
Come on.
Yeah, let's look for red squiggles. Oh, there's a big one. So we can't register component resource because there's no new.
Deployment. This is a production app. I'm remembering now the reason why I call this production app rather than deployment is so that I could search for errors because we're using the Kubernetes SDK and deployment and it returned a bunch of stuff. So that should be a production app.
All
there
right.
we go.
No more red.
Come on, we can do this.
I mean, I don't have any confidence in me, but I know you two will get it. Let's see. Let's use VS Code here. It's normally quite good at telling us where the reds are. Although everything looks all right. So if the code's not complaining and Go's language server's happy, maybe now it's a schema thing?
Maybe. I'm also going to... Can you rename deployment.co to production app with a capital A just to make sure that it's like...
So
after all this, it'll be a... Yes, so just rename that to production app. With a capital A. There we go. And let's take a final look at the schema.json.
Yeah, this still has deployment here.
So that needs to be deployment. That's the actual, that's the resource that's going to be generated. So that's okay. I'm just going through this line by line at the moment. Required inputs. Yeah, no, that's right.
I'm going to try it.
I believe in you.
Yep, I'm wrong.
Can you do me a favor? Can you git commit what we have? And like, I have a working instance of this, and so I'm going to start copying code over to see what we've missed.
Oh yeah, of course. Yeah, go for it. So just add everything.
Yeah, just do an initial commit.
YOLO. And push. Did I clone my fork? Yeah. Did I? Yeah. Well, that's not going to work.
Yeah, I don't think you need to push it. Just having it locally is probably good enough.
All right. I thought you wanted to maybe.
No. I'm going to do a git diff when I start copying stuff over.
Oh, yeah, cool.
Basically, makes sense.
Yeah.
So this is my schema.json, and the only difference here is that I added an output. So I'm going to save that. And if you go to git diff now to see what the differences are.
Did you save it?
Oh no, I didn't. No.
All right, so the description's changed. Image imports the other way around, but other than that, there's no go definition anymore.
It's a little bit further down. Look.
All right.
There we are. So you can see the package name and the import base path are obviously set to things that I would have. If you generate that, see what happens. It's probably going to fail because the import's wrong. But...
Oh.
Nope, it worked.
So, what?
What's different here?
So the descriptions, the input property ordering, like none of that can matter, right? The output URL, I'm not fussed about. I don't think that's important. So it must be just.
So that was, I obviously didn't get a chance to actually get this done last night, but the idea here is that this production app will output a URL from our load balancer. And so eventually we'll get to the point where we can update this. So what I would recommend here is let's update the import base path to actually remove my name and do Rawkode instead of my GitHub username Jack Storm, and then rerun it. But now that we have this in Git, I can go and have a look and see what was different, basically. So let's rerun that.
Still works.
Must just have been a typo. See, this is the problem. Like, what we're actually hoping to do is actually emit this JSON schema rather than build it manually, so you can't make these mistakes. I think this is a great example of like why using these kind of like untyped documents can be so difficult. The only part of this that we had trouble with is this untyped part. So let's also remove the properties and required outputs because we're not going to use those. So if we open up our so that properties is an empty map, and then required, and then so we should be able to rerun that.
No, it's good. Oh, Paul left us. Thanks for saying bye.
See you later, Paul.
Thanks for your help.
Okay. Yeah, we appreciate it. So that's the schema that's generated. So now we should be able to do make build as well. So what this is going to do is it's going to... Sorry, go ahead.
I was just going to I liked what you were saying there as I was trying to type and kind of think at the same time. But like the schema can be inferred from the canonical implementation, and you're working on generating the schema from like the Go structs or the TypeScript things.
Yes.
Or something. Okay, awesome.
That's exactly what you said. Like, so the Go, that part of the reason why we've got that Pulumi definition on the Go structs is we are working on kind of generating this schema manually. I mean, I guess you could implement a validator on the schema as well, but like I think it's kind of telling that the one part of this that we had to hand write basically without any type hints caused a bunch of problems. And it's still not clear what that problem was. I hope you're going to git commit this so I can go back and look at it later.
Yeah, I'll push it up. Don't worry.
So just to talk about what's actually happening here, so you obviously don't have .NET installed, so let's just update the make file and not generate the .NET part.
Okay, so on build, we do not want .NET SDK.
And we don't want to install it either, so if you look at the make file as well, while that's running, we'll do remove install .NET SDK. Yeah. So yeah, again, to just talk about a little bit about what's happening here, like what this is doing is it's building us a binary that we will then distribute to our users. Usually you would install this with Pulumi plugin install. And that will get, it either needs to be in your Pulumi directory or in the actual path of your on your machine. So it's doing a go build, and it's actually generating the schema. If you look after the rm-rf, it's going to clear out your bin directory. It's going to generate the actual schema, which ends up being a Go file, which is why we were getting that error earlier for Pulumi schema. And then it's going to build a binary that you would distribute. And now here is the point where it's going to generate all the different SDKs, so the Python and Node.js SDKs.
So are these like, when I, say I wanted to ship this now, like I'm just pushing the code to GitHub and Go developers can import it from that source. For TypeScript, am I publishing to NPM? For Python,
That's
I'm
exactly
publishing to PyPy? Right, okay.
That's exactly it, yeah. So you would need to push the packages to all of your respective package managers. You also need to distribute a binary to the users. We are working right now on automatically generating, automatically being able to grab that binary from when you do the npm install or the PyP install. This already happens with Pulumi for all of our kind of like multi-language providers. When you do npm install at Pulumi Kubernetes, it pulls down the binary for you, and so you'll be able to do the same process basically. These actually end up looking just like those like Pulumi providers. So it's a binary and then an SDK. I see you running in the install command now, so this should create a yarn linkable package for us that we can then use in our example.
All right, so does that mean we want to create a Pulumi TypeScript application now to be able to consume?
I generally put in an example so that everybody can see what it looks like. So I'll do make directory examples and then TypeScript.
Okay, new directory, example, TypeScript, and we want to do a Pulumi new in this?
Yes.
Okay, example, TypeScript, Pulumi new. And
TypeScript.
Just TypeScript.
I just do Pulumi new TypeScript, yeah. Yeah, that should work.
Let's see how that installs there. Okay, that's done.
So now you should be able to run yarn link, and the reason that I told you to update, so obviously you can't publish this to the @Pulumi org, so now you would publish this to @Rawkode in npm, so we can yarn link that package inside that example. Yeah.
Provider? No.
No, just yarn link is fine. It's already in, like the install make already did that, right? And so then we can open up that example, that TypeScript example, import all. Yarn link is magic. Don't pretend to try and understand it. @Rawkode.
Wow.
And then you should be able to do const Rawkode.
Yeah.
Equals new.
It's a class, right?
Yeah. And then we also need a name, so let's just call this example.
Yeah, so name and then args. So example, args. I don't think the autocomplete's quite kicked in there yet, but we know that it's a image.
And it's cap, I think, yeah. So then the image would just set in Nginx.
I think I need to do yarn install first.
It's because you're using Rawkode too many times. So you need to do, if you go back to your, so const, there we go.
Yeah, I wonder if that fixes the autocomplete. Yeah, there we go. Okay, so deploy Nginx, we got our port.
So we should be able to Pulumi up this if you've got your Kubernetes, and again, this is a component resource, so you could pass providers to this if you wanted to. This is just a standard Pulumi application. Should be able to do Pulumi up.
So I do have a kube context set. There's no pods running. We run a Pulumi up. Oh, TypeScript. Just wanted to make you sweat a bit. That was all.
Oh man, I was panicking then.
All right, so help me understand what this is actually doing. Right, we have linked to the Yarn generated SDK, which is generating types so that TypeScript is aware of what we have available to us. But is it it's calling out to a Go binary, right, to do the actual deployment and the service and such?
I am not the person to explain this, but I'm going to do my very, very best, right? So what this is doing is it generates all of the actual like SDK, and then just this registers inside the actual Pulumi engine. So that's what the binary is doing, is it basically takes the TypeScript, converts it into like a schema implementation, and then the Pulumi engine does all of the work. So that's why it's really useful to write these in Go, because you can just distribute that binary and it can go straight to the Pulumi engine. This is really, really kind of like deep technology, and I'm not going to profess to understand quite how it works at its full level. And I even asked before I came on, I was like, somebody's going to try and explain how this works to me, because it's literal magic. Like, we've written a program in one, we've written something in one language and we are able to consume it in another language. It's just wild to me. And this will work with Python. It will work with Go. We've obviously made a mistake with our Kubernetes definition rather than with the actual Pulumi program. So if you do a new terminal, do kubectl, it's probably something silly. Kubectl get namespace.
And, just hook up my. Yeah, it has created the namespace.
So kubectl get po minus yeah.
Oh wait, why am I doing?
You're doing get.
But I think the service has been created. It's got it's actually got an IP, a load balancer IP, and stuff like that. But it's never going to find any pods because we've missed something in the spec. And we can wait for this to time out and see the error. I don't know if I'll get the error.
10 minutes. It's 10 minutes, so it takes a little while.
Right.
So what I would do is Control C out of that and then Pulumi destroy. Here we are. There we are. Required value for
Selector.
container pod.
Or no.
It looks like our actual types aren't coming through properly. So our input types aren't coming through properly. So I think there's a problem in the two things that we specified as arguments aren't actually coming through, propagating all the way through from the schema. So let's take a look at that, see if we can get it working.
That's not the right file, is it? That's the other one.
Yeah, it's in the...
Nope. This one.
It's in the production app. Yeah, that's the one. Yeah.
Okay. So
you know what it is? I mean, maybe you can spot what it is. Yeah, you've already spotted it. Yeah, that's why. So you can see there the relationship between the schema and the actual structs. It's because we'll need to regenerate the SDK now.
Yep.
So make generate, make build, make install.
I've got this. I know what I'm doing.
You're a hero, man. You're doing a better job at the developer advocacy part than I am at this point. So.
Well, Paul's given us some hints for the mistakes we're making along the way in the chat as well, but I'm just going to ignore him because he left us. So. All right, so we'll give this a few seconds. I don't think we need to change anything on our TypeScript side, right? So we're linking to the dependency. So really, if we just run a Pulumi up again, hopefully those two parameters are being pulled through correctly, and we'll get our deployment. Okay. Pretty magic if it works.
I mean, like obviously this is the first alpha-ish release of a very, very powerful thing, and part of the reason why I wanted to do this live with you is just to kind of get an idea of obviously I'm pretty close to it, so I kind of know all the little things that we need to iron out, but being able to explain it and see those things, we've got a lot of, we've got some really exciting authoring improvements coming through as well, so we expect this to kind of get better and better over time.
Nice. I think it's definitely solving a real problem. Like I said, I work in cluster API bindings that are using Pulumi and TypeScript, and they're not consumable by people that don't want to use TypeScript. And like right away, I could just see that I want to go and do this and generate the type. So the implementation language is almost irrelevant to a certain point.
Yeah, absolutely.
All right, let's go for it. Let's see.
So it should tell us it wants to update the deployment because that never got created, and the service has changed. So that sounds like it's a good sign.
It worked. It's creating a replica set.
Magic.
Deployment initialization complete. So now it's waiting for the pods and images. In fact, it's already done.
And so let's take a look at actually how long have we got left. I want to kind of run through some more.
Yeah, 10-15 minutes. More.
So let's take a look at the SDK directory and see what actually happened here. So if we open up, if you look at the SDK, we've generated the things all in and we can write a Go example as well probably. But you can see, look, if you look at the package.json, it's just a standard npm package, which is called Rawkode. This version gets like updated and it goes into the bin directory, so that's what we yarn link. So if you open up that bin directory in Node.js, you'll see that should have the correct version. But you'll see, look, this has got all the types and stuff that's actually been generated for us. And if you actually look, the thing that kind of is crazy to me is if you look at the deployment.d.ts or the deployment.js, all it's doing is deploying all it's doing is creating the actual shape of this thing. All of the work is actually done in the Pulumi engine. So it's not defined. We're not generating a Pulumi program. We're just generating the types and the schema, and then the Pulumi engine does all of the work, which I think is just wild, right? Like, I think it shows the power of the Pulumi engine to be able to show that you can kind of do these things. And then there's also the Python SDK as well, so that obviously is available to us.
Your favorite one, right?
My favorite. What I'd like to do, if we can see if we can get it work with replace, is do a Go version of this as well. But again, like this is just the input types that we've got for each of the different SDKs, and that's basically it. Like we've generated a consumable thing, and some of the things that I keep thinking are like I created a Pulumi AWS load balancer controller multi-language component, which I think is an amazing use case for this, because if you think about the AWS load balancer controller as an example, generally to install it, you're going to need at least 2 different things to actually get it working. You're going to need CloudFormation to deploy the AWS IAM roles and all that kind of stuff that it needs to use, and then also something like Helm or Kubernetes YAML to deploy the Kubernetes parts. With the AWS load balancer controller Pulumi multi-language component, it just works. Like it deploys everything in one go. And I'm really excited about creating things like production-ready implementations of Helm charts is a really, really good example. Rather than kind of running a bunch of Redis replicas inside, inside Kubernetes, you can use your cloud provider's hosted Redis to be able to do that. And I think Paul already mentioned he did a amazing implementation of Google Cloud's Cloud Run multi-language component, which allows you to just specify, all you need to do is specify an image, and it deploys a multi-region global Cloud Run across all of Google Cloud's infrastructure in a single line of code. It's so powerful. And the other thing as well is if you are writing things like Terraform modules or all that kind of stuff, or CDK constructs, you can essentially write these Pulumi multi-language packages, and instead of kind of going into one ecosystem, either the HCL ecosystem or the AWS ecosystem, you can go to all of our supported language ecosystems and all of our supported cloud providers. So the reach is really, really, really far.
Awesome. Very, very cool. Well, all of your bits worked. So I'm now really curious if my bit worked and whether I can actually browse to this application. And my fear is not, but damn.
Maybe. Did we specify a port? We didn't specify a port, did we? Oh, we did 80, yes, and it's Nginx, so it should be working. Oh, well.
Well, there's something for me to fix later. What I will do is just port forward to it. Well, at least I can pretend some of my stuff works. 80, 80, 80. Hey.
Look at that.
It's the simple things that keep me happy.
So what I like if you commit this to GitHub, you know, this is a great like kind of like teaching example, like a nice and simple, straightforward example of a multi-language component. Again, one of the things that's missing here is you're probably going to want to pass the load balancer output to other Pulumi resources, or maybe the namespace that's been created. So the next step would be to add those outputs, and that would again go in the schema. So you would say the URL, for example, is a great way of kind of exporting that thing. And then again, you can pass these things and create dependencies between these things. So you could say, let's say you wanted to register a DNS name for the IP address. You could use another Pulumi provider like the Cloudflare provider, pass that output into the DNS output, and you know, you're kind of off to the races, basically.
Nice. Awesome. Very, very cool and powerful system for working with Pulumi. It's really cool to see that, and just I'm really impressed that it worked.
Well, I mean, like I said, I'm pretty happy. The only problem we had a problem with is the JSON schema. We know that there's improvements needed there, and we're working hard on those kind of improvements. But It just shows you handwrite something, and you're gonna have problems, right? Like.
Yeah, but those things, right, like improving the authoring experience, as you mentioned, those are just quality of life things. People can, you know, start to take advantage of multi-language runtimes and packages now, allowing them to, you know, just like you said, deploying to Kubernetes and Helm charts, like being able to have idiomatic or convention-based approaches per organization or per team, and satisfying that through Pulumi packages is a pretty solid way to start doing.
Yeah, and we've had like large customers who have large engineering organizations who are, you know, seeing the capabilities of this and realizing that, you know, it means that they can bring in different organizations who perhaps don't want to write things in Go, perhaps don't want to write things in TypeScript. You know, they're multiplying their capabilities, and like we have customers who are creating internal SDKs that kind of abstracts all of the stuff away in a similar way that we did. To allow them to kind of really provision infrastructure really, really quickly.
Awesome. There's just two small questions if you're happy to take them, and then I'll let you get back to your day. So Fanny asks, is it Open API schema, the schema.json?
No, it isn't. It's a structure of the actual internal Pulumi schema, which is not Open API. It's all done over gRPC and protocol buffers. It's mainly just a declaration of what things look like. If we think, I don't think there would be much value in turning that into an Open API schema. We are documenting the schema, and maybe we could use Open API to make sure that everybody knows what that looks like. But the best thing that you have right now is just to take a look in the example that we put together and kind of fill it out from there.
I think you should abandon the JSON and use Q for this, but I'll preach the Q goodness to you another day.
I'm still in the JSON at church. I haven't come out from that yet. So.
All right. Last question, Andreas, who also thanked us for the Bleeding Edge demo. I'm going to show that again because, you know, I do appreciate you joining me today, Lee, and walking us through this. But Andreas asks, is this the same quotes magic that allows us to use the providers? Is it based on the same system as the providers being consumed for multi-languages?
That is exactly right, yes. So what we've done here is we've taken the magic that we have with our providers that we use to, like, when we bridge them from Terraform providers, or when we create the Kubernetes and Azure native providers. It's the same technology. And what we've done is just kind of extend it into Pulumi components, and we register those components inside the actual Pulumi engine. So the great thing about this is if and when we add another language, and we're still talking internally about what that language might be and when that will be, I'm sure I'll get messages asking for Ruby and Java and all that kind of stuff after this.
Rust.
We haven't made decisions about this yet, but the point I'm going to make is when we do add support for that language, updating to that version of the SDK, let's say hypothetically people, when we add Java support, all you'll need to do is update to the latest version of the SDK, and it will generate those language bindings for you. And you will get, every single time Pulumi will add a new language SDK, in the same way that we get for the providers, like Java support will come in. It will happen for the components as well. So it's exactly the same technology, super powerful. Magic. Isaac Asimov said, indistinguishable from magic.
Awesome. All right. Paul Stack says, can't wait to see those Equinix metal packages. You're damn right. Those are coming soon. And we've got one last question from Andreas, and then that's it. I'm leaving it there. Andreas is asking, could you say some words about the isolation between two components from a runtime perspective? Read NPM dependencies. Does that make sense to you?
I think so. If I'm not getting this right, Andreas, then please feel free to reach out to me on Twitter at Briggsl. Essentially, the runtime dependencies are basically, because we built this in Go, we obviously need to actually bundle the Go dependencies into the binary, which is, from a user perspective, like not completely transparent. They don't need to know about that. When we generated the SDK, if you remember, we looked at the schema.json really early on, and we defined what those runtime dependencies were, because we know we're going to use the Kubernetes SDK. And so that when we generate that SDK, for example, NPM or PyPy, it generates a package.json with those dependencies in there. And so you as the user have full control over what dependencies the thing needs. An example that I'm putting together right now is, you might, one of the things, I'm going to write one of these in Python, God forbid, but I'm also going to try and update and it's going to be an IAM type provider that uses Parliament as a, as a linter for those IAM profiles, IAM policies. That will need to be installed when you actually kind of install the component itself, but you have control over what the user installs. There's no cross dependencies between these things, so as a Go author, I don't need to tell them to install any Go modules or Python modules. It's just the actual runtime that they're selecting.
Awesome. All right. Thank you very much, Lee. It's always a pleasure to spend a bit of time with you, even more so when you're showing me Pulumi awesomeness. If anyone does...
Great to...
Sorry. If anyone else does have any more questions, I've stuck Lee's Twitter handle on the screen. I'm sure he'd be more than happy to help you. He's also very active in the Pulumi Slack, which I would encourage you all to join and ask loads of awesome questions about this magic that is happening here. Any last words, Lee?
No, I really appreciate kind of spending time with you and not being under the pressure of fixing a Kubernetes cluster. So yeah, it was really great, and I'm looking forward to kind of coming on next time we have more awesome features and showing them off.
Awesome. I cannot wait. All right, you enjoy the rest of your day. I'm going to finish for today. I will speak to you soon. Everyone that watched, thank you. Have a great day. Awesome.
Thanks. Bye.
I just clicked finish and it said video not found. So we're going to do this lo-fi. Bye-bye.